All right, in the previous problem, we plotted this line, this equation, and we graphed it out onto there. And I'm going to show you a quicker way to do this same thing. Because we already have this equation written in what's called the slope-intercept form. It's the slope-intercept form. So what this equation is, it's telling us exactly where all these points are. What the slope-intercept form does, it gives us first the slope, which is often represented as an m of the equation. What slope is the rise over the run. How much does the line go up and down is the rise. And this is a way you can remember it. Rise goes up and down. And the run goes left and right. Now, when we look at our graph in our coordinate grid there, if you notice, the y line is the one that goes up and down. So the y is going to be associated with the rise. And the run is the one for x that goes to the left and right. So the run is going to be associated with the x. All right, so that's something to kind of help us to remember. Slope is what goes, how the line goes up or down or side to side. And the rise is how much it goes up and down. The run is how much it goes side to side. So just drawing here, if we had some grids, if I had that grid and I said the line was like that, similar to what we just had, okay, that's what we call a positive slope because it's going from left to right in an upwards form. When it goes upwards like that, that means it's positive. If we had a grid and the line was going this way, things are going down, so that would be a negative slope. All right? Even if it doesn't go up or down much, if I have this and I say that the line is going like that, it's still positive. It's just not a very steep slope. Or if I draw one that goes almost straight up and down, that would be negative, and it's a very steep slope. So this helps you to kind of see what slope is. Now, the other thing with our formula that we're looking at here, with slope-intercept form, we see that it's slope. Well, in this equation that we have written here, the reason that we know it's in slope-intercept form, slope-intercept is y equals mx plus b. This is available on your formula sheet, on the test. It's available in a lot of places that you would be able to get to. So you don't have to necessarily memorize it, but if you do memorize it, it'll make things a lot easier because you'll be able to start to see, like when we saw this equation, I instantly knew that it was in slope-intercept form because the slope is whatever's in front of x, and the y-intercept, which is the intercept of this, is whatever's after the plus. And it can be plus or minus. Sometimes I like to draw it like that, plus or minus b, because it doesn't matter. As long as I have it set up this way, the same way on the problems up here, we got it set up into the y form. And for the next one that we did, we had it set up into the y form. We wanted to solve for y. That's what the slope-intercept form is. As long as you put it in this order, like we've done here, it tells us what the slope is and what the y-intercept is. Now, what is the y-intercept? The y-intercept is where this line is going to cross the y-line. So we have this graph, or this equation that we're going to be graphing, and it says on the y-intercept, which is the y-line, it is going to cross at -1. So instantly I can look at this and go, okay, -1 on the y-line. Oh, that's right here. That's where -1 is. So I'm going to go ahead and plot a point at -1 because it tells me that's where it crosses the y-line. Now, that's just a point. To make it a line, we have to look and see, well, what's the slope? How much does it rise and how much does it run? So when I look here at the slope, which is m, the slope of this in front of the x there is 3/4. And again, think, and I write this on my paper not just to show you, but this is one of the things I do every time I'm working these so I can make sure I get this right. Rise and run. It rises 3 and it runs 4. And is it positive or negative? Well, it doesn't have a sign in front of it, so that lets us know that it's positive. If it was negative, it would have to have a negative sign. So I know that it's going to rise or go up 3, and it's going to run or go over 4. So from here, I can go up 3, 1, 2, 3, and then I'm going to run 4. 1, 2, 3, 4. I can go up 3, 1, 2, 3, and I can go over 4. 1, 2, 3, 4. To go the other direction, because it has to rise, I'm actually going to go down 1, 2, 3, and then run back 4. 1, 2, 3, 4. Go down 3 and back 4. And if you notice, my line goes straight through those points, just like the line that we drew above it. It's the same equation. We use the same equation here. The y equals 3/4 x minus 1. And if you notice here, on our one that we plotted using our t-square, where we plotted some points, if you look at it, we used -1. That was one of our plot points. And then the other plot point was 4, 2, which if you notice on this one, we're at x4, y2. On the top one, x4, y2. Then we had this point, -4. X is -4, y is -4. Same thing here. X is -4, y is -4. And we even had more points doing it this way. This is one, once you set it up into the slope-intercept form, you'll be able to plot any of these equations just by knowing what the y-intercept is and what the slope is. This is something we're going to practice more in the next little bit.